Hello everybody and welcome to today's lesson on solving radical equations. Our objective for today is we will solve equations containing radical expressions algebraically and graphically. So how do we solve rational or radical equations? Our ultimate goal is to eliminate the radical or rational exponent. In order to do that, we must perform three steps. The first one is to isolate the radical or the rational exponent term. Then we need to raise both sides of the equation to the reciprocal. And when I say reciprocal, I mean the reciprocal of the rational exponent. And then we solve and, very importantly, check our solutions. Checking our solutions is so important because we always have to check for extraneous solutions. Some of our solutions do not make sense. They are extraneous solutions, and therefore we need to check to see if those solutions we find algebraically are actually solutions that work in the original equation. So let's see and find some species of equations you may see in the wild, or maybe just on a practice sheet. The cube root of 8x plus 3 minus 5 is equal to negative 2. First, we need to isolate the radical. So, in other words, we're adding 5 to both sides. So we have the cube root of 8x plus 3 left by itself. And we have positive 3 on the other side. And since this is a cube root, in order to eliminate the radical, we need to raise this expression to the third power and do the same thing on the other side. So on the left we get 8x plus 3, and on the right we get 27. And now we're going to go ahead and solve. Do the rest of the solving work. Subtracting 3 from both sides, we get 8x is equal to 24. Dividing by 8, we get x is equal to 3. Now let's see if that works. Plugging 3 back into our original equation, we get 8 times 3 plus 3. The cube root of all that minus 5 is equal to negative 2. Or, in other words, the cube root of 24 plus 3 is 27. Minus 5 is equal to negative 2. The cube root of 27, yes, 27 is a perfect cube. It is actually 3 cubed. But if you're not sure why, don't we use a calculator? Math, and 4 will get you to the cube roots. Cube root of 27, enter, and yes, that's indeed 3. So 3 minus 5 is equal to negative 2, or negative 2 is equal to negative 2, and this solution checks out. Now in this equation we have a rational exponent but essentially we follow the same steps. First, we need to get that term with the rational exponent by itself, isolated. That means we need to add 8 on both sides, and we get 2 times 2x plus 3 to the power of 1/3 is equal to 6. And now we can divide both sides by 2. So the quantity 2x plus 3 to the power of 1/3 is equal to 3. And in order to get rid of our rational exponent, we need to raise the entire thing by the reciprocal, in other words by 3. And remember, if we raise a power to another power, we end up multiplying the exponents, and 1/3 times 3 is 1. So we have eliminated our exponent, and that is exactly what the inverse operation does. 3 cubed is 27. How very original, right? Anyway, so next step, we go ahead and solve this equation now. Subtracting 3 from both sides, we get 2x is equal to 24. Dividing by 2, x is equal to 12. Let's check out the solution. Plugging 12 back into the original equation. 2 times 12 plus 3 to the power of 1/3 minus 8 minus is equal to negative 2. 2 times 27 to the power of 1/3 minus 8 is equal to negative 2. 27 to the power of 1/3, in other words, the cube root of 27, we just had that, that is 3. So 2 times 3 minus 8 is equal to negative 2. 6 minus 8 is equal to negative 2. Negative 2 is equal to negative 2. Check. So this solution also checks out. Now in our next example, we have a rational exponent which looks a little different. We have both numerator and denominator different from 1, so we need to take care of that specifically. So let's get going. First, we isolate the term with the rational exponent by subtracting the 22. So 3x plus 5 to the power of 7/3 is equal to 128. Now we need to raise both sides to the reciprocal of 7/3, which is 3/7 on the left. That's fine because the two exponents cancel each other out, and we end up with 3x plus 5. On the right, on the other hand, we now have the 7th root of 128 raised to the 3rd power. I wrote this as a radical so we can see it more clearly and do the two operations separately. So let's see if we can simplify anything about the 128, and in order to do that, the easiest way is to just quickly do a factor tree. 128 is 2 times 64, which is 2 times 32, 2 times 16, 2 times 8, 2 times 4, and 2 times 2. So how many 2's do we have? 1, 2, 3, 4, 5, 6, 7 2's all in all. And we are in luck because we need the 7th root of 128. That means 3x plus 5 is equal to the 7th root of 2 to the 7th power, all raised to the 3rd power. And the 7th root and the exponent 7 cancel each other out. We end up with 2 cubed, which is 8. 3x plus 5 is equal to 8. Subtracting 5, we get 3x is equal to 3. dividing by 3, our answer is x is equal to 1. And let's again check if that actually works out. So 3 times 1 plus 5 to the power of 7/3 plus 22 is equal to 150. 3 times 1 is 3 plus 5 is 8. 8 to the power of 7/3 plus 22 is equal to 150, or the cube root of 8 raised to the power of 7 plus 22 is equal to 150. Now the cube root of 8 is 2. 2 to the 7th power plus 22 is still equal to 150. 2 to the 7th power we have just found out is 128. 128 plus 22 is equal to 150. Yes, that is indeed the case. And check. Well done so far. Now go ahead and watch the second part of this tutorial.